Okay, let's test this out with a difference quotient example. Let's let our function be a quadratic function, maybe x squared plus 3x plus 1 as an example. And we're going to calculate the difference quotient for function f. Now the definition of a difference quotient. It is a quotient of two differences. The first difference is f evaluated at x plus h minus f of x. The second difference is x plus h minus x. And it turns out that this ratio can be simplified, and so if you're memorizing this formula, you may just want to memorize it as f of x plus h minus f of x all over h. Notice in the first ratio that in the denominator x, take away x, becomes 0. Okay. So then to put this into practice with our function, we need to take f of x, which is the input squared, plus 3 times the input plus 1. And first we take the sum squared plus 3 times the sum plus 1. You can think of grouping symbols around that. You don't need them, but then you subtract the entire polynomial all over h. The polynomial evaluated at the sum minus the polynomial just with x all over h. Now we expand the polynomial. X plus h squared, of course, is going to be a trinomial. We'll distribute the 3 through the parentheses. The constant 1 remains the same. We are going to need to then subtract x squared, subtract 3x, subtract 1, and eventually we will simplify the fraction. Now if we've done these difference quotients correctly for polynomials, we're going to have some terms that add up to 0, maybe some other terms that add up to 0 that we can strike out. And look here, the constant 1 take away 1 becomes 0. And our difference quotient reduces to the cross term 2xh plus h squared plus 3h. I believe that's the only terms remaining in the numerator. We're dividing by h. Every term has an h in it, so our answer will be 2x plus h plus 3.